Good morning, welcome to EduMath Zone. So, welcome to our exam special series. So, we have been discussing set chapter. Yesterday, we have completed up to 9 problems. So, we shall continue for 10th problem onwards. So, now the 10th problem under 1 mark questions. 10th problem. Write A equals to, this we need to read as A equals to, or A is equal to -3, -2, -1, 0, 1, 2, 3, 4. In set builder form or into set builder form. Set builder form. So very good, very good. Welcome you all. So now we need to express this one into the set builder form. First you check down the elements. What are the elements present in the set? See, -3, -2, -1, 0, 1, 2, 3, 4. They are the integers. Integers means denoted by the letter Z. That means if you say the element is X, X belongs to Z, but one condition is there. What is the condition? It lies between -4 to 5, or we can write in between -3 to 4 also. -3 less than or equal to X, X less than or equal to 4. If you mention this property, then it becomes the set builder form. So let us write set builder form. Set builder form is here given this one. A equals to -3, -2, -1, 0, 2, 3, 4. Now set builder form for this given set A. It may not be set A, set B, set C, set E also we can say. A equals to, we can write X such that X belongs to integer, or X is an integer also we can write, and also what is the condition? -3 less than or equal to X, X less than or equal to 4. So this is the set builder form. Okay, 11th question. Write or express, whatever it may be. Write B, this time set B. B equals to 2, 5, 10, 17 into set builder form. Set builder form. So first we need to check for the common property of the elements of each and every element of the given set B. Now the set B is given in the roster form, that is to be expressed in set builder form. See, first you check the property of 2. So this 2 can be written as 1 square, 1 plus 1. 5 can be written as 4 plus 1, that is 2 square plus 1. 10 can be written as 3 square plus 1. 9 plus 1, 10. 17 can be written as 4 square plus 1. So that means actually here, see, now here given, what is given? B equals to 2, 5, 10, 17. So now this 2 can be written as 1 square plus 1. 5 can be written as 2 square plus 1. 10 can be written as 3 square plus 1. This is 4 square plus 1. So that means it's very clear. Here 1, 2, 3, 4. In the place of this 1, you write, in the place of 1, 2, 3, 4, write down n. That becomes n square plus 1. Say in the place of this one, say x. This is x is equal to n square plus 1. and also n value will be 1, 2, 3, 4. So this can be written as n less than 5. N is also what kind of number? 1, 2, 3, 4 are counting numbers, natural numbers. Okay, so now we can write like this. Set builder form for this one. So B equals to x such that x equals to n square plus 1, and n is a natural number. N belongs to n. This symbol is belongs to. And what is the condition? N must be less than 5. N must be less than 5 means 1, 2, 3, 4. So this is very important. You practice at least very important one. So you need to practice this one. This is very important question. It may appear in the examination also. So now the 12th one. Write C equals to x such that x equals to 1 upon n, n belongs to n, and n less than or equal to 5 in roster form or into the roster form. This time we need to express in the roster form. Here see, it is given by the general formula. What is the general formula? Here x will be in the form of 1 upon n, and n is a natural number. Second condition. Welcome you all. So n is equal to natural numbers means 1, 2, 3, 4 and dash dash. But one condition is given. N less than or equal to 5. N less than or equal to 5 means n becomes obviously 1, 2, 3, 4 itself only. That means in the place of n, 1 substitute, you get 1 by 1, next 1 by 2, next 1 by 3, next 1 by 4. These are the elements of the set. So these elements we should write. That will be the roster form of the given set. So let us write it now. So now the solution. Here given C equals to x such that x equals to 1 by n, n belongs to n, and n less than or equal to 5. So therefore C equals to, you can write like this, 1 by 1, comma 1 by 2, comma 1 by 3, comma 1 by 4. 1 by 1 is nothing but 1. So 1 comma 1 by 2 comma 1 by 3 comma 1 by 4. My dear students, you remember you are able to write the set builder form into the roster form and roster form into the set builder form. So that you need to practice more problems on this one. Definitely in the examination for 2 marks and 4 marks you will be getting this question. So writing set builder form into the roster form or roster form into the set builder form. So 13th question. Write this time set D. Always you need not take set A, set B also. Set D, set E, set F also you can take, no problem. X such that x is a prime divisor or prime factor of 60 into roster form. Express this set into the roster form. So how could you proceed? X is such that x is a prime divisor of 60. So that means divisor means factor of 60. That must be prime factor. Factor as well as prime factor. So prime numbers. First see what are the prime numbers. Let me write the, for your sake, the prime numbers will be like this. Primes are prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and so on. They are the prime numbers. They are the prime numbers. So first prime factors of 60 you find out. So prime factors of 60 means, see, you can find out like this. So 230 ja, next 215 ja, next 35 ja. So that means 60 can be written as 2 into 2 into 3 into 5. So what are the prime divisors of 60 or prime factors of 60? Prime factors of 60 is 2, 3, 5. This is repeated 2. Take only one 2. 2 comma 3 comma 5 becomes the actually roster form for this one. So first let us write the solution. Here given D equals to X such that X is a prime divisor of 60. So this is to be expressed in roster form. So how could you express? Therefore D is equal to, set D is equal to, what are the elements you will be getting? Actually 2 comma 2 comma 3 comma 5. In set, element should not be repeated. Take one time only, 2 comma 3 comma 5. So this is the answer. Okay, welcome you all. 14th question. 14th question. Write set E equals to 5 comma 125 comma 5 comma 25 comma 125 comma 625 into set builder form. Set builder form. Set builder form. So we need to write in the set builder form. So this you check here. So we need to check for the property. We need to search for the property of this element that which possess in the given set E. So that means 5. What do you write? You keep 5 only. 25, you can write 5 square. 5 into 5. 125. 125 is 5 cube. 625 is 5 to the power of 4, you can write. So that means this we can write 5 to the power of 1. So that means generally you say this is x, you say this is equal to 5 to the power of something, say n, but n is the what? 1 2 3 4. N is equal to 1 2 3 4, natural number. And also what is the condition? N must be less than 5. So these three, using these 3 points, key points, we need to express this one into the set builder form. So now the solution here given E equals to 5 comma 25 comma 125 comma 625. So this can be written as a 5 powers. 5 to the power of 1, 5 square, 5 cube, and 5 power 4. So therefore set E equals to x such that the element x is equal to 5 to the power of something, 5 to the power of n, write down, where n is a natural number and condition n must be less than 5. So this is the set builder form. So you might be understanding all these questions. Now 15th one. So let's have a discussion on the 15th question. So all of you just watch till the end of the session. That's very important. You need to concentrate. 15th question. Represent mu is equal to, mu is a universal set, 1 comma 2 comma 3 comma 4 comma dash dash 10. This is the universal set, and a set a equals to 2 comma 4 comma 6 comma 8 comma 10. So 2 comma 4 comma 6 comma 8 comma 10 are even numbers, or we can say multiples of 2, okay, or in the form of 2n form. That is, by Venn diagram, the great mathematician John Euler introduced the Venn diagrams to represent the sets, or visual representation or illustration of the sets in Venn diagrams. See, first of all, in order to represent universal set is represented by the rectangle, whereas the closed circles or even closed some oval shape also you can take for the sets. So given mu, so you need to pronounce as mu equals to 1 comma 2 comma 3 comma 4. That means 5 6 7 8 9 10 up to 10. There are 10 elements in the universal set. Out of this universal set, A is one of the sets, or subset also we can call, 2 comma 4 comma 6 comma 8 comma 10. So now Venn diagram. How to draw the Venn diagram? Venn diagram, first actually mu. This is the mu. Rectangle shape. You take rectangle is mu. In that set A, you take set A. This is. First, you write the elements of the set A. This is the set A. What are the elements? 2 comma 4 6 8 2 4 6 8 10. Already written. After writing 2 4 6 8 10, remaining elements out of this A you need to write. What are there? 1 is there. Next 3 is there. 5 is there. 6 is there. 7 is there. And 8 is there. 9. Next 9 is there. 9 write down. 9. Completed. 1 3 5 7 9. 1 2 3 4 5 6 7 8 9 10. So this, in this way we can represent it. Venn diagram using it can be expressed or represented, illustrated we can call. So 16th problem. So let us move to the 16th problem. All of you there now? Yes or no? If A equals to 2 comma 5 comma 6 comma 8, set A, set B equals to 5 comma 7 comma 9 comma 11, then, so very good, then find A union B comma A intersection B comma A minus B and B minus A. See, this is very important question. Everybody actually should be able to find out A union B, A intersection B, A minus B, B minus A. Suppose even you are able to find out A minus B union B minus A also. So how could you find? Here see the solution. Given A equals to 2 comma 5 comma 6 comma 8 and B equals to 5 comma 7 comma 9 comma 11. Okay, first let us find out A union B. It may be called only A. So that means 2 comma 5 comma 6 comma 8 minus 5 comma 7 comma 9 comma 11. So that means we need to take it away 5 comma 7 comma 9 comma 11 elements from set A. 5 cancel, 7 cancel, 9 cancel, 11 cancel. What are the remaining elements in here set A? 2 comma 6 comma 8. This is called only A because 5 is in both A and B. That element need to be deleted. So we get now 2 comma 6 comma 8. This is A minus B. This is A minus B. Now we are asked to find out B minus A. B minus A. So how could you find out B minus A? B is 5 comma 7 comma 9 comma 11 and minus 2 comma 5 comma 6 comma 8. Only B means common elements of both need to be gets cancelled. So now here 5 cancel, even 2 also cancel, 6 also cancel, 8, all these elements have been cancelled out. So what we have remaining here? Here we have 7 comma 9 comma 11. This is called A minus B union, A minus B. This is called B minus C. Now even we can find out A minus B union B minus C also. How could you find out? Sometimes that question may be asked in the examination also. A minus B union B minus A. Already A minus B we know. First A minus B we need to find out. So that is 2 comma 6 comma 8. 2 comma 6 comma 8 union B minus A. What is B minus A? B minus A. B minus A is 7 comma 9 comma 11. Just club it. Club all the elements. So we get like this 2 comma 6 comma 7 comma 8 comma 9 comma 11. That's all. So now you are able to find out A union B, A intersection B, A minus B, B minus A. So these are all called operations on sets. Different operations can be performed on the two sets. Not only two sets, it can be operated more than two sets also. Now the 17th question. So let's have a discussion on the 17th question. 17th question. If A equals to 1 comma 3 comma 5 comma 7, generally they are odd numbers. Now B is equal to 2 comma 4 comma 6 comma 8, they are even numbers. Okay, then find A intersection B. Write your observations. So what do you notice that is meaning, or what do you observe? Write your own observations. So first simply find out intersection of these two sets, A intersection B, find out. Then your observations need to be written, expressed. So now the solution right on. Here given A equals to 1 comma 3 comma 5 comma 7 and B equals to 2 comma 4 comma 6 comma 8. So now find A intersection B, because you are asked to find out A intersection B. This is important. Set A is 1 comma 3 comma 5 comma 7 and intersection 2 comma 4 comma 6 comma 8. What do you mean by intersection? The common elements we need to write. What are the common elements in these two? Nothing, only braces and empty. This is nothing but pi. if A intersection B is equal to pi, then our observation we can write A comma B are disjoint sets. Disjoint sets. Otherwise, they are said to be overlapping sets. If A intersection B is not equal to pi, then we say that overlapping. This is called disjoint sets. Sometimes you may be asked the definition of the disjoint sets also. Simply write down if A intersection B is equal to pi, then A comma B are said to be disjoint sets. So now 18th question. 18th question. Let us move to the 18th question. Write all possible subsets. All possible subsets. Possible subsets. Subsets of B is equal to P comma Q. So P comma Q. So okay, welcome you all. So write all possible subsets of B is equal to PQ. So that means actually subsets means no element subset, that is pi. So one element subsets we can write P and Q, and at most we can write two element subset, that is P comma Q. Total we get 1, 2, 3, 4 subsets. This list out, that's all. So now the solution. Given set is B equals to P comma Q. So therefore possible subsets. Possible subsets for B are, first one is null set. Null set is the subset for every set pi. One element set P, Q also. Same set, that is P comma Q. So these are the possible subsets. If two elements are there, then there exist four subsets. In that, pi is the one of the sets, and even same set also. 19th question. 19th question. Shravani says A is equal to X such that X plus 5 is equal to 5. X belongs to whole number is a null set. Do you agree with her? Justify your answer. Justify your answer. Justify your answer. Okay, you need to justify with the Shravani if it is correct. Otherwise, you can say yes or no, you need to say. So first, A is equal to X such that X plus 5 is equal to 5. X is a whole number. Whole numbers means 0, 1, 2, 3 like that. So that means you need to solve this equation. If the solution is the element of this whole number, then it is not a null set. It may have the one or two elements. If nothing, no element is there, that is a null set. Otherwise, we can say that it is not a null set. So that means first of all you solve it now. If you solve this equation, what do you get? X plus 5 equals to 5. X equals to 5 minus 5. So you get 0 because 0 is a whole number. 0 belongs to whole number. That means one element is there in this set, 0 element. So it's not a null set. So that means We do not agree with her because it is not a null set. So now the solution, given A is equal to x such that x plus 5 equals to 5, x belongs to whole numbers. That means this we need to change into the roster form 0. So one element is there, it is not a null set. So now therefore, no, I do not or I don't agree with her. Okay, here that implies A is not a null set. This is called singleton set. This is called singleton set. No, I do not agree with her. Absolutely correct. So 20th question. 20th. If A equals to 1, 4, 6, 9, 10 and B equals to perfect square numbers below 25, then represent A intersection B using Venn diagram. So that means you are asked to draw the Venn diagram for A intersection B. So how to represent or illustrate A intersection B using Venn diagram means, first we need to find out A intersection B, then you draw. If A intersection B is not a null set, then we need to draw the overlapping sets. Otherwise we need to draw the disjoint sets. So now the first, let us proceed like this. Here given A equals to 1, 4, 6, 9, 10 and B equals to perfect square numbers. Perfect square numbers means 1, 4, 9, 16, 1 square, 2 square, 3 square, 4 square, below 25. Below 25 means after that 5 square you will be getting 1, 4, 9, 16. Now let us find out A intersection B, and after that we need to represent using Venn diagram. So set A is 1, 4, 6, 9, 10 and intersection 1, 4, 9, 16. So that means what are the common elements? You see 1, 4, 9, 1, 4, 9. So that means we need to write this one as A intersection B is equal to 1, 4, 9. Now Venn diagram. So Venn diagram you need to draw. So first rectangle you take it. Rectangle is for universal set is mu. Now you take set A, you take set B, this is set B, set A, set B, because overlapping, they are sharing common elements. So first common elements right now. So what are the common elements here? We have 1, 4, 9. This part is called A intersection B part. already 149 is there. In A still we need 610. So that means here write down 610. 610, this blue color also, A minus B also we can write. In B already we have 149, only we require 16. Here 16 write down. So in this way we can represent it. If you want, you can shade like this also. You can shade this part. You can shade this part. This is called A intersection B. A intersection B. So 21st problem. 21st problem. Give one example for finite set and infinite set. Finite set and infinite set. You are asked to give examples. So that means finite set means only actually the elements, the number of elements are countable. So or we can say that the cardinality of the set is finite. That means otherwise we can say that whole number. Then that is called finite set. If the cardinality is not defined, that is said to be infinite set. So examples we need to write. What are the examples? Solution you can write. First example for finite set. So you give like this. A is equal to 2, 3, 5, 7 right now. So example for infinite set. So that you say set B is equal to natural numbers 1, 2, 3, 4, 5, so on dash. This is called infinite set. Simple example you shall give it. So now the 2 marks problems. 2 marks. Right. 2 marks, sometimes it may be 4 marks also in the examination. Don't worry. So now let us go for 22nd question. The question number is 22nd only, but weightage may be 2 marks. If A equals to 1 minute, let me come. Right. A equals to x such that x belongs to n, x less than 6, and set B equals to x such that x belongs to natural number 3 less than x less than 9. Then show that A minus B does not equal to B minus A. They are not equal. So using Venn diagrams that means you need to draw the Venn diagram for A minus B and B minus A. Then we need to say that the two portions will be different portions after shading in the Venn diagram. That we need to just express it. We need to prove it. We need to illustrate it. Right. So first of all, A is equal to x such that x belongs to n, x less than 6. So this is to be read as b is equal to x such that x belongs to n, 3 less than x, x less than 9. First we need to write this is set builder form, sorry, roster form. This also roster form we need to write it. So first write down solution. Given say a equals to x is a natural number and less than 6. What are the natural number less than 6? We can write 1 comma 2 comma 3 comma 4 comma 5. That is a. So now write down b. b is equal to x is a natural number lies between 3 and 9. That means you can write start with 4, 5, 6, 7 and 8. That's all. So now we need to find out a minus b. A minus b we need to find out. So now find a minus b. A minus b. So that is 1, 2, 3, 4, 5 minus 4, 5, 6, 7, 8, 9. So take away all the elements of b from a. So now 4, 4 cancel, 5, 5 and 6, 7, 8. So this equals to we have 1 comma 2 comma 3. Next b minus a. So b minus a means from b take away the elements of a. So 4 comma 5 comma 6 comma 7 comma 8 and minus 1 comma 2 comma 3 comma 4 comma 5. So now here 4 4 taken out, 5 5 taken out and next even 1 2 3 also. So remaining what are the elements we have? 6 comma 7 comma 8. This is b minus c. So what is the common elements in both? What are the common elements? 4 is the common element. Here 4 is also common element. 5 is also common element. 5 is also common element. So now draw the Venn diagram. So now Venn diagram means you need to draw like this. Okay. This is set A. This is set B. Set A, set B. This is mu. First common elements right. What are the common elements here? We have 4 5. So 4 5 right. So next this is 1 2 3. This red color is actually red color part is a minus b part. Next take a dark color. B minus a 6 comma 7 comma 8. So now you shade like this part up to this part. Prime factor of 30. Then draw Venn diagram for A union B. For A union B. So first write A in set builder form, write B in set builder form. First of all, solution right now. Given A equals to x such that x is a natural number and x is a factor of 30. Factor of 30. So what are the factors of 30? First let us write. So that we can write in set builder form like this. So A equals to we can write 1 is a factor, 2 is a factor, 3 is a factor, 3 divides, 4 does not, 5 divides, 6 divides, 7, 8, 9, 10 divides, 15 divides and 30 divides. So these are the factors of 30. This is roster form. And we have B equals to X such that X belongs to N and X is a prime factor. X is a prime factor. Prime factor of 30. So out of these, what are the prime factors? Prime factors means here B equals to, we can write 2, 3, 5. Only 3. 2, 3, 5. This 2, 3, 5 actually contains in B. 2, 3, 5 are there in A. That means B is the subset of A. B is the subset of A. So how to draw the Venn diagram for A union B? So now find A union B. A union B. So A union B equals to, here A is 1, 2, 3, 5, 6, 10, 15, 30 and union B. B means 2, 3, 5. 2, 3, 5 repeats. So we get again union means clubbing all the elements 1, 2, 3, 5, 6, 10, 15, 30. That means you get again, you will be getting A union B is equal to. That means if B is the subset of A, if B is the subset of A, then A union B is equal to A. So that means here how to draw the Venn diagram means, you take like this, first rectangle, this is mu, you take A, in that you have B like this. First elements in B write down, that is 2, 3, 5. Already 2, 3, 5 written. Remaining elements write down. What are the remaining elements we have? Remaining elements we have 1, 6, 10, 15, 30. That's all. This is the figure for A union B. Venn diagram for A union B. Actually you get like this, overlapping or disjoint, or it may be one set lies inside of other set. 3 types of Venn diagrams you will get it. So 24th question. 24th question. If A equals to X such that X belongs to the natural numbers and X less than 16, X is less than 16, and B equals to X such that X is a prime number, X is a prime number, X is a prime number, and X less than 20, and X less than 20, then show that or prove that A minus B does not equal to B minus A. That we need to prove that A minus B and B minus A are not equal sets. So that means first of all you see, first write this A in roster form, write B in roster form. After that find A minus B separately, B minus A separately. Just observe A minus B and B minus A have the different elements, and so they are not equal. We can say that, we can conclude that A minus B does not equal to B minus A. So let us proceed for the solution. Given A equals to X such that X belongs to N, X is a natural number and x less than 16. Less than 16 means we can write A equals to elements of the set A is equal to list form or roster form 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is A. Now B equals to x such that x is a prime number. X is a prime number. Prime number means it has only two factors, that is 1 and same number, and x less than 20. So we need to write the prime numbers below 20. That means what are the prime numbers? You get 2, 3, 5, 7, 9 is not a prime number, 11, 13, next 14 is not, 15, 17, and next 18, next it is not, 19. So these are the prime numbers 2, 3, 5, 7, 11, 13, 17, 19 are the prime numbers less than 20. So now what we need to find out first? Now we need to find out A minus B. A minus B. A minus B equals to 1, 2, 3, 4, 5, 6, 7, here 8, 9, 10, 11, 12, 13, 14, 15, and minus B. B means prime numbers 2, 3, 5, 7, 11, 13, next 14 is not, 15 is not, 16, 17, and next 19. Okay, so now 2, 2, 3, 3, 5, 5, 7, 7, 11, 11, 13, 13, 17, 19. So remaining elements right now. What are the remaining elements only in A? 1, 4, 6, 8, 9, 10, 12, 14, 15. This is A minus B. This is A minus B. So now let us find out B minus A. B minus A. What is B? 2, 3, 5, 7, 11, 13, 17, 19. They are the prime numbers. And minus natural numbers less than 16. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Here now what we need to do? 1 cancel, 2 cancel, 3, 3, and next 4, 5, 6, 7, 8, 9, 10, 11 cancel, next 12 cancel, 13 cancel, next 14 cancel, 15 cancel. We have only remaining two elements, that is 17, 19. Just observe from equations 1 and 2. What do you observe? From equations 1 and 2, we notice that or observe that A minus B and B minus A are not equal. A minus B is not equal to B minus A. It's completed. Okay, thank you. We shall continue tomorrow also. So, thank you. Bye bye.